What's up, everybody? Welcome to Earth Saints. Hope you're doing well. Let's talk about lag and what that means. What does it mean, like in a video game? If you're playing this one, Clash Royale, right? If you're playing a first-person shooter, if you're playing Fortnite, lag would be like if you go and you hit the button and try to shoot somebody, but by the time that it actually gets to the server or back to that person, they've already run away because your computer is lagging. You're running a little bit behind. Why am I talking about this? Well, it happens in nature too. It happens both on a daily basis, which all you got to do with that is check out that little infographic right there. It also happens on a yearly basis, and that's what you're going to do with all these intimidating looking numbers. Don't worry, the lab's not that bad. What you're going to do is plot for the whole entire year, but only on these dates to make it a little easier, all of the insolation, and I wrote that right over here, incoming solar radiation, basically that term for, it's like sunlight, but describing sunlight in terms of its energy. They do it here. This is kind of a crazy unit. Don't worry about it too much, but it's kilowatt hours per meter squared per day. I actually went and found a website that people that just install solar panels use to get all of these numbers. And I got about 10 years worth of data, and I put them all into a spreadsheet, and I averaged them all. So this is, and it's set for Pulaski, New York. So these are numbers that work locally. And you'll see how that changes throughout the year. Now, you should already kind of know how it changes throughout the year because we've already worked on seasons. During what seasons do we get the most energy? During what seasons do we get the least energy? And remember, that all has to do with the angle of the sun. The higher it goes in the sky, the more efficient it is at heating the planet. So that's what you're going to do. You're going to graph that out. Now, I put all the numbers for the whole entire year here. You got what month? So month 1 is January, month 2 is February, and so on. You got what day. Then you got the insolation, how much energy is hitting Pulaski, and then we'll talk about the temperatures in a minute. And that runs through all of these columns. Since I use real data from the internet, there's gaps. Now, I don't know if that's because whoever set this up had faulty equipment on those days, and it had to be all of those days. Or my guess is probably that they don't register it on days that are cloudy because that would like mess with the data. So these are probably only the clear days throughout the year. So yes, we have a couple that didn't quite get a report. Hey, Mr. F, what if I've got to report a number, but it's not there? Well, think about it and figure it out. If it's 2.3 on this day and 2.3 on this day, what do you think it was on those days? You know what I'm saying? If it's 2.6 here, 2.7 there, what do you think it was there? I bet you can figure it out. You know, a tenth here isn't going to be a tremendous difference on your graph anyway. So throw it right about where you think it belongs according to what's just before it and just after it. You'll be fine. It'll work in the graph. So what you'll do is pick one color dot for insolation, and you're going to use this axis. So January 1st, we've got a value of 2.2 kilowatt hours. I'm going to recommend doing the same thing we've been doing. Go with maybe size 6, pick a color, and then 2.2 is our value. So there's 1, there's 2, there's 2.5, 2.2 is probably right about there. Cool. January 10, also 2.2. 2.2. Bam. January 20, what is it? See what I'm saying here? You guys can do this. 2.6. Oh, baby, it's going up. All right. So do that. That'll give you a curve for purely for the energy, purely for the sunlight, purely for what part of this, like what amount of energy out of the sun is hitting Pulaski. Now, as it turns out, the temperature doesn't go right along with that. I mean, take a minute, forget about all this for a minute, and just think in your head. When's the hottest time of year? Is it June 21st when we've already said the sun is at its peak? When's the coldest time of year? Is it December 21st when we already said the sun is at its minimum? It's not. It's after. There is a lag, just like the same concept as this. The energy happens, and then after that, because of the radiation balance, there's a lag between when we get to the highest temperatures, right? So you're going to plot that out as well on here. So it's kind of like there's two graphs on one physical graph, but that's going to allow you to compare the two and see what they really look like. So just do the same thing. Notice there's some negatives. Zeros right here, and we go down to the negatives. So let's see what we got. January 1st, the temp is negative 0.3. What you'll want to do here is pick a different color. So negative 0.3, there's negative. So each box is worth 2 here. So negative 0.3 is like just barely below it. Maybe right about there. January 10, negative 1.3. It's getting colder. Think you got it? One more? What the heck? Okay. And I guess that kind of shows the lag already because we've already had our lowest point of sun energy, insolation. That's starting to rise, but hey, temperatures are still going down. So that already within 3 points on each graph is demonstrating what we're looking at here. When you're done, you'll have a nice curve in one color for insolation, a nice curve in another color for temperature. Then you can come back and work these questions. And then try at the end here to give me a good little paragraph explaining what lag is. Go back to this video, look at the parts that I explained it, read this little thing that I stole from this website right here, and think about why we have this difference from when we get the peak insolation to when we get the highest temperature, and when we get the lowest insolation to when we get the lowest temperature. Why is there that difference in time? Good luck, everybody. You'll do well. We'll talk to you soon.